In this video, we are going to talk about the inverse of a matrix, and we'll start with the 2 by 2 matrix and then 3 by 3 matrix. Generally, for any matrix, the inverse of the matrix, if I have a matrix A, for example, the inverse of A is the ratio of the adjoint of the matrix A to the determinant of A. That's the adjoint of A, or the adjugate of A, divided by the determinant of A. So, to determine the inverse of a matrix, we need the adjoint of the matrix and the determinant of that matrix. Alright, take note of this. The adjoint of a matrix, is the transpose of the cofactor matrix. Or the adjoint of a matrix is the transpose of the matrix of cofactors. Okay, so we need to determine the adjoint now, we need the cofactor of each of the elements in the matrix. Take for example this 2 by 2 matrix. Let's find the inverse. We have the matrix A equal to, alright, I want to find the inverse of this matrix. So I need the adjoint and the determinant. I can easily get the determinant. Okay, for every 2 by 2 matrix, the determinant is this: minus 2 times minus 4, that's 8, right? This times is 8, then minus 3 times 5, that's minus 15, minus minus is a plus, so we have 8 plus 15, right? And that's what? 23. So the determinant of this matrix is 23. Let's now determine the adjoint of the matrix so that we can get the inverse. The adjoint of a matrix, like I said earlier, adjoint is the transpose of the cofactor matrix. To obtain the cofactor, we use the formula Cij is equal to minus 1 into I plus j times the minor. This is the cofactor and this is the minor. Okay, I represent the row and j represents the column. That's it for everything. So I want to determine, before I can determine the cofactor now, I need to get the minor. It is very easy to determine the minor. This element here, minus 2, is in the first row and in the first column. This is the first row, this is the first column. 5 is in the first row, this is the first row, and in the second column, this is the second column. So minus 3 is in the first column and in the second row. That means the second row and the first column. So I'll write A21. Minus 4 is in the second row, second column, A22. Okay, let me determine the minor of minus 2. That's M11. It's very easy to get. I will eliminate this column of minus 2 and eliminate this row of minus 2. What will be left is just 4, minus 4. Close up this and close up this, we have minus 4 left. So the minor of the element minus 2 is minus 4. To obtain the minor of this, the minor of the element 5, that's M12. Close up this entire column where minus 5 is found. Close up the row where minus 5 is found. We'll be having minus 3 as the minor. Minus 3. To obtain the minor of minus 3, that's M21. Close up this row and close up this column. What will be left? 5. If I close this up and I close this up, this down, we have 5 left. So the minor of the element minus 3 is 5. And the minor of the last element minus 4, that's M22. If I close up this column where minus 4 is found, and I close up this row where minus 4 is found, we'll be having the element minus 2. So minus 2 is the minor of the element minus 4. So we can now determine the cofactor of each of the elements here using the formula. The cofactor of the first element here, that will be C1, 1, is equal to minus 1 raised to the power of I plus j. I is the row and j is the column. I is 1, j is 1. So if I add 1 and 1 together using the formula, I'll have 2 times the minor of this element. The minor, which is M11, is minus 4. Minus 1 squared is 1. 1 times minus 4 is minus 4. That's the minor of this. And this is the cofactor of this element. The cofactor of this element now, as C12, is this. Minus 1 to the power of, using the formula, we add the row and the column. 1 plus 2, that's 3. They will multiply by the minor of that element, which is M12, and that's minus 3. And what would that give us? Minus 1 to the power of 3 is minus 1. Times minus 3 is 3. That's the cofactor of the element 5. The cofactor of the element minus 3, that's C21, is minus 1 to the power of 2 plus 1 is 3, times the minor of this element, which is 5, right? Minus 1 to the power of 3 is minus 1, times 5 is minus 5. And the cofactor of the last element there, which is the cofactor of minus 4, that's C22, is minus 1 to the power of 4. Of course, 2 plus 2 is 4, times the minor of this element, which is minus 2. And that will be minus 2. Minus 1 raised to the power of 4 is 1, positive 1. So 1 times minus 2 is minus 2. So the cofactor matrix is this. The matrix of cofactors, let's say it is C. Okay, let's use C to denote the matrix of cofactors. That will be C11, C12, C21, C22. Alright. What C11 is minus 4. What C12? 3. What C21? This is minus 5. And what C22? Minus 2. This is the matrix of cofactors. The adjoint of the matrix A is the transpose of this cofactor matrix. To transpose this matrix, I will interchange the rows and the columns. Look at it. The first row here has minus 4 and 3. That will be the first column. Now, minus 4 and 3. And here we have minus 5, minus 2. That will be the second column. Minus 5, minus 2. This is the transpose of the cofactor matrix. This is C transpose. We just transpose this matrix, and this is it. And it forms, or it gives the adjoint of the matrix A. So the adjoint of this matrix is what we have now as the transpose of this cofactor matrix. A shorter way to determine the adjoint of a 2 by 2 matrix is this. We may not always need to do this cofactor minus stuff all the time for inverse, for adjoint of a 2 by 2 matrix. We can just do this. Okay, see what we're going to do. Inverse is still adjoint divided by determinant. So for the adjoint, we can do a very simple thing. The adjoint of A for a 2 by 2 matrix is this. This is the matrix A. I will interchange the positions of these two elements on the principal diagonal. Minus 2 will be here, minus 4 will be here. So this will be minus 4, minus 2. Then you see these two numbers, I will multiply them by minus 1. Multiply this by minus 1, it becomes minus 5. Multiply this by minus 1, it becomes 3. This is the adjoint of the matrix, without doing all the minor cofactor stuff. And that's what we got as the adjoint of the matrix. So the inverse will now be divided by determinant. The determinant of the matrix is 23, right? The inverse of the matrix is the adjoint divided by the determinant. Of course, this is minus 4, minus 5, 3, minus 2, divided by 23, which I can write as 1 over 23 times the matrix times the adjoint. Okay, so multiply everything inside by this 1 over 23. We have the inverse equal to that will be minus 4 over 23. This will be minus 5 over 23. This will be 3 all over 23. And this will be what? Minus 2 all over 23. This is how to find the inverse of a 2 by 2 matrix. Alright. Let's now find the inverse of a 3 by 3 matrix. Alright. The same procedure. I have a matrix A, 2 minus 1, 3, 1, 0, minus 2, minus 3, 4, 1. I want to find the inverse of this matrix A. Recall that inverse is the ratio of the adjoint of the matrix to the determinant of that matrix. And the adjoint of a matrix, like I said, is the transpose of the cofactor matrix. So let us determine the cofactor matrix now. Cofactor is minus 1 to the I plus j times the minor of the corresponding element. Okay, so let us determine the minor of each element in this matrix. 2 is in the first row and in the first column. So the minor of this element here, that's M11, is this. If I eliminate this column of 2 and I eliminate this row of 2, I'll be having the element 0, minus 2, 4, 1. 0, minus 2, 4, 1. For a 2 by 2 matrix, the minor of every element is a single number, right? But for a 3 by 3 matrix, it is the determinant of the matrix obtained when the column of that element is closed and when the row is closed. So when we close this column and we close this row, we are going to obtain this element 0, minus 2, 4, 1. The minor is the determinant of 0, minus 2, 4, 1. You get it? 0 times 1 is 0, minus 4 times minus 2 is minus 8. That will be plus 8. And that's 8. So the cofactor, the corresponding cofactor, that's C11, is this. Minus 1 to the power of I plus j, that's 1 plus 1, times 8, which is the minor. 1 plus 1 is 2, alright. Minus 1 to the power of 2, that's 1, positive 1, times 8 is 8. This is the cofactor. We'll now go to the second element, minus 1. Minus 1 is in the first row, in the second column. That's first row, second column, M12. It is the determinant of the matrix obtained when we close up the column of minus 1 and when we close up the row of minus 1. We'll be having the elements 1, minus 2, minus 3, 1. 1, minus 2, minus 3, 1. 1 times 1 is 1, minus 3 times minus 2 is plus 6, right? 1 minus 6 is minus 5. And the corresponding cofactor of that element, that's C12, is minus 1 to the power of 3. Of course, 1 plus 2 is 3, times the minor, which is minus 5. It will give us 5. Minus 1 cubed is minus 1, times minus 5 is positive 5. The minor of the next element, that's M1, 3, that's this element now, is in the first row in the third column. That's first row, third column. It is the determinant of the matrix obtained when we close up the column and the row of 3. If we close up this column and we close up this row, we'll be having the element 1, 0, minus 3, 4, right? 1, 0, minus 3, 4. 1, 0, minus 3, 4. So the determinant of this gives the minor. 1 times 4 is 4. 0 minus 3 times 0 is 0. And that's 4. So the corresponding cofactor of the element 3 is minus 1 to the power of, this is 3 rather, C1, 3 to the power of 4, because 1 plus 3 is 4, times the minor, which is 4. And what would that be? That will be 4. Because minus 1 to the power of 4 is 1, times 4 is 4. And then we come to the second row now. We have this. Okay, this is in the second row in the first column. That's the minor M21. That's for this. Is in the second row, but in the first column. That's why we have 21 here. So if we close up this row and we close up this column, we'll be having the elements minus 1, 3, 4, 0, 4, 1, minus 1, 3, 4, 1. That's all we have left. Minus 1, 3, 4, 1. Minus 1 times 1 is minus 1. Minus 3 times 4 is 12. What would that be? Minus 13. So the corresponding cofactor of that element 1, as C21, is minus 1 to the third. The minor of the element 0 in the second row in the second column, this is it. The second row in the second column is the determinant of the matrix obtained when the column of that number is closed and when the row is closed. So if I close up this, okay, where 0 is found, I will close up this row where 0 is found, also this row, we'll have the elements 2, 3, minus 3, 1. 2, 3, minus 3, 1. 2, 3, minus 3, 1. And this is the determinant. 2 times 1 is 2, minus 3, minus 3 times 3 is minus 9. So we're having 2 plus 9, that will give us 11. And so the cofactor of the element 0, that's C22, is minus 1 to the fourth, because 2 plus 2 is 4, times the minor, which is 11. And what would that be? That would be 11. Because minus 1 to the power of 4 is positive 1, times 11 is still 11. And then we look for the minor of this element minus 2. Minus 2 is in the second row in the third column. That's M23. Alright, if we close up this column of minus 2, this third column, and we close up the second row, we're having the element 2, minus 1, minus 3, 4. So what's the determinant of this matrix? 2 times 4 is 8, minus 3 times minus 1, that's plus 3. That's 5. So the cofactor of that element minus 2, that's C23, is negative 1 to the fifth, right? Because 2 plus 3 is 5, times the corresponding minor, which is 5. And that will give us minus 5. We now come to the third row. All right, and the minor of that element, the first element, the third row, which is minus 3, is M3, 1. In the third row, in the first column, eliminate this row, eliminate this column. We'll be having minus 1, 3, 0, minus 2. Minus 1, 3, 0, minus 2. Minus 1 times minus 2 is 2. 0 times 3 is 0. And that will give us 2. So the corresponding cofactor, C31, is negative 1 to the fourth. Okay. Because 3 plus 1 is 4 into 5. Sorry, into 2 is it. And that will give us 2. Because minus 1 to the power of 4 is positive 1. Now, look at the minor of this element 4. The minor of this element 4, that's M32, is the determinant of the matrix. If I close up this row and I close up this second column, I'm having 2, 3, 1, minus 2. 2, 3, 1, minus 2. 2 times minus 2 is minus 4. 1 times 3 is 3. That will give us minus 7. And the corresponding cofactor is negative 1 to the fifth into minus 7. And that will give us positive 7. And lastly, the minor of the last element in the matrix M33 is this. If we close up the last column and we close up the last row, we'll be having 2 minus 1, 1, 0. 2 minus 1, 1, 0. Okay, so determinant is 2 times 0 is 0. 1 times minus 1 is minus 1. That will be plus 1, which is 1. The corresponding cofactor of the elements is negative 1 to the fifth, to the sixth rather, because 3 plus 3 is 6, into the minor, which is a 1. And that will give us positive 1. There is actually a shortcut to determine the cofactor of an element. Okay, you know, for every 3 by 3 matrix, we have it in this form: plus, minus, plus, minus, plus, minus, plus, minus, plus. The signs alternate, starting from the first one, which is positive. Okay, so if I know that the minor of an element is 8, for example, I will just multiply that value of the minor by the place sign of the element. See what I'm saying? 2 is positive, that's the place sign. So multiply plus 1 by 8, that will be 8. Minus 1 has a place sign of minus, right? And the minor of minus 1 is minus 5. So if I multiply minus 1 by minus 5, I will get plus 5. Check this. 4 here has the minor of minus 7. Okay, minus 7. If I multiply the place sign of 4, which is minus, by minus 7, I will get a positive 7. 1 here has a place sign of minus, and the minor of 1, which is M21, is minus 13. So if I multiply minus 13 by the place sign of 1, which is minus, I will get plus 13. So we can now go ahead to determine the cofactor matrix. Let's write the matrix of cofactors. Let C represent the matrix of cofactors. C11, C12, and C13, that's 854, will be on the first row. 854. Then we have C21, C22, C23, that's 13, 11, minus 5 on the second row. 13, 11, minus 5. C31, C32, and C33 will be on the last row. 271. Okay. 2, 7, 1. This is a matrix of cofactors. The adjoint of a matrix is the transpose of the cofactor matrix. The transpose of this matrix, that's C transpose, is the matrix. We interchange the rows and the columns. This becomes the first column. That's 8, 5, 4. This becomes the second column. 13, 11, minus 5. And this becomes the last column. 2, 7, 1. And this is the adjoint of the matrix A. To get the inverse, we need the adjoint and the determinant. That's what the formula says. Okay, so what now is the determinant of this 3 by 3 matrix A? We can easily do that. The determinant of matrix A is this. For the first element here, 2. 2 has a place sign of plus. I think I said that earlier. That was plus 2 multiplied by the minor. Alright? Eliminate this column, eliminate this row. We have 0 minus 2, 4, 1. 0 minus 2, 4, 1. Minus 1 is there. It has a place sign of minus. Multiplied by its own minor. Okay? That's eliminate this column, eliminate this row. We have 1 minus 2 minus 3, 1. 1 minus 2 minus 3, 1. 3 has a place sign of plus. Eliminate this column and this row. We have 1, 0 minus 3, 4. 1, 0 minus 3, 4. So let's simplify this to get the determinant of the 3 by 3 matrix. That's 2 in bracket. 0 times 1 is 0 minus 4 times 2 is minus 8. Minus minus will give us a plus. Minus minus is a plus, so we have plus 1 in bracket. 1 times 1 is 1 minus. Minus 3 times minus 2 is plus 6. Plus 3. 1 times 4 is 4. Minus. Minus 3 times 0 is 0. What would this be? 0 plus 8 is 8. Times 2, that's 16. 1 minus 6 is minus 5. Times 1 is minus 5. 4 minus 0 is 4. Times 3, that's 12. 16 minus 5 is 11. 11 plus 12 is 23. 23, that's the determinant of this matrix. The adjoint of the matrix is this, and the determinant is 23. That's what we got, 23. So therefore, the inverse of the matrix, that's A inverse, is the adjoint of the matrix divided by the determinant. This is the adjoint. 8, 13, 2, 5, 11, 7, 4 minus 5, 1. Divided by the what? The determinant, and that is 23, all over 23. So I can write this in two ways. I can say the inverse of A is this. I can write as 1 all over 23 into the adjoint. That's 8, 13, 2, 5, 11, 7, 4 minus 5, 1. Alright, I can take this as the inverse of the matrix, or I can multiply every element in that matrix by 1 all over 23 to get this. 8 times this, that's 8 all over 23. So this is also the inverse of the matrix. Anywhere I write it, I'm correct. Alright, this is how to determine the inverse of a 3 by 3 matrix. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like this video, and share the video with your friends and your classmates. I will see you in the next one. Keep following.